So first of all, what we started with, like if I have been given an instruction, how do I encode it? So we are trying to understand that encoding technique. Okay, now and we are trying to understand the encoding technique by decoding the original instruction. Okay, what are the object code that we are getting? So let me share my screen. Is my screen visible?
Yes, sir.
Okay, good. Okay, so terminal. So this would be like now I will be talking mainly about a code which I'm going to write for understanding maybe some different kind of instructions or different kind of patterns with respect to the operands that we'll be able to see exactly there. Right? So let us try to really see that program, like where it would not be simply saying kind of like say for example move register to register. No, we are going beyond that. Fine. So let us write it. Okay, so I'm talking about now a code where I have an array, okay, which is declared like this. So you can recall like I tried adding 4 into that particular register to increase that, and we tried printing that array. So I'm taking similar kind of code. So we'll end this by -1. So section.bss some resd. So we'll store some into this variable. And now our code. Okay, now I'm declaring a variable 4.
Sir, you are not audible.
Okay, I have muted. Okay, don't worry because I am typing the code. ECX comma. Okay, now I want to make use of this ECX as an index. So XOR ECX comma ECX. Now what exactly I want is, like say for example, now how will I compute address of this array? If at all I have to print, I have to really access array elements from here. How do I access this? So element would be accessed like this. Element would be array of I. That's how you write, correct? For I equal to 1 to n, element equal to array of I, which you are going to read. Now when you refer this I, how exactly this I is computed? So you say this is an index, but actually it is not like that. So it is computing like this. This is index. Okay. Address would be like this. Suppose address is array, because array, this is a name given by you, but in memory, actually it is an address. So this is address array plus index multiplied by size. So like if address is 10, if address is 100, say for example here, next address would be found at where? Because it is declared with DD, so ultimately it would be taking 4 locations further, correct? So if you recall in previous session also I wrote ESI plus 4, ESI plus 8 and so on, correct? So that's how. So index multiplied by size. Now in this case, when I see this 10, like if I talk about 10, say how that 10 would be. So assume that array address is 100. Now index is 0 multiplied by size. So this will be found on 100. Now next number, when I talk about 20, where would the 20 found? 100 plus index is, it is first element multiplied by 4. So this would be found on 104. Now next number is 30. How do I get it? 100 plus 2 multiplied by 4. So the next third number would be found at 108. This is how the computation would be. So I want each number to be added with sum. So first of all, I need to bring that number there. So how do I calculate this 100, 104 and so on? So first of all, I need to take this index. So I took ECX as index. Correct. This 4 I'm storing with EX every time. Fine. Now I will write mul ECX. What will happen? What is the value with ECX now currently? Because of XOR, it is 0. Am I right? This is actually ECX equal to 0. So I'm taking value of 4, which is shown here, like which I added here as 4 here. So you can even remove this. You can simply write 4 if you don't want that to be added there. Correct. And then you are writing like this. So instead you can do this. So suppose move EDI, comma keyword of ESI plus ECX multiplied by EX. So do you see it is like this? Array plus index multiplied by size. Can you see this? Am I right?
Yes, sir.
Okay. Now when I exactly know that size is going to be 4. So can I write like this even? But the problem is multiplication instruction requires what parameter to be in EX. That's why I wrote this EX here. So instead of this, what I'm doing is, instead of this statement, I'm writing like this: move EX comma 4 mul ECX. Okay, add ESI comma EAX, because what is this now? EAX equal to EAX multiplied by ECX. So this multiplication actually is stored with EAX because of this instruction. Now I'm adding this into ESI. Ultimately, I'm doing what? ESI plus this multiplication. So this multiplication is stored with EX. So I got now address. Correct. Address is computed. So I got, say, for example, 100 now with respect to our assumption. So now I have to add keyword of I have to add it like this: add d word of sum, comma d word of ESI. Correct. But as per standards of Intel, I cannot have an operation with memory to memory in both the cases. So what I'm doing here, EDI, comma d word of ESI, and I'm writing add d word of sum, comma EDI. So instead of this memory to memory, I'm using a temporary variable, a temporary register, in this case EDI, which would be holding that value. Correct. And then when it's done, I will increment ECX because I have to increment that index. EX will remain same. ESI also should have the same value. So sorry. Where is this ESI? So we'll keep it here only. Because every time we are adding that into this base is 100 in, and now ESI, we are assuming that ESI is containing 100. So 100, and we are going to repeat this. So increment ECX. Now till what you are going to do this? So you are saying this. So you see, you check here CMP EDI comma -1. If it is -1, then jump to 0, print. If not, then add. So it will continue here. Now increment ECX, and then it is unconditional jump to LP. And now it should go here again. Now here we will write print. Now print is what? Push d word of sum, push MSG, call printf, add ESP comma 8. Now we have to write here external printf. Now why I'm writing this code? I want to show you remaining mods. That's the reason. Okay, let us see whether are we. So what would be the sum in this case? 10, 20, 30, 40, 50. What would be sum now if I add this array? Yes, please. What would be sum of these elements? If I add 10 plus 20 plus 30 plus 40 plus 50. Am I audible?
149.
You don't want -1, na? I said only 50.
$150, sir.
150. Let us see whether are we getting it. If there are errors, we will try to correct them. Can you see sum computed? So if you change that code, change in the sense the data 110, 220, 330, 440 and 550. What would be sum? Yes, what would be sum? Will it be 1650?
Yes, sir.
Correct. Let us check. So that means our code is correct. Now let us debug. Breakpoint main. So let us display the values EAX, ECX, then you want ESI, EDI. Let us do this. OK, run. So now we are moving values NI, NI. ECX is becoming 0 now. Check. Is ECX 0? Yes. ESI is getting address of array. So if you compute, what is the initial value of at ESI? So first value is 110. You can see this, correct? So NI, CEX is changed. ECX is 0. EX is 4. So you are writing mul ECX. NI. EX became 0. So add ESI comma EX. So there is no change. Correct. We are moving value of that address to EDI. So first value should be in EDI is 110. Are we getting it? Yes. Compare whether it is -1. No. Now see where it is going. Jump if 0 to print. It is not 0 because they are not same. EDI and -1 are not same. That's why 0 flag would not be set. So let me show you E flags. So if at all, like while it reaches to -1, you will see ZF written there. OK, you will see that. It is not, so it is going to print statement. Can you see that? That print was here. So you are adding that because print is not, it is not 0. So that's why it is adding that EDI to sum. NI. Increment ECX. ECX is 0. 1. Jump to LP. Now see, you are at line number 30. It is taking you to line number 19 directly. Again, so it is a loop, kind of for loop. Now you are getting ESI as array address again. Right? Add EX, move EX, 4. Mul ECX. Now let us check first what is value of ESI. ESI is currently 110. Now when you add 4 into this address, so this would be becoming 8, 9, 10, 11, 12. 12 means what? A, B, C. So let us see whether it is showing you here C. So NI. Correct. So like C is shown in this way because this is a number. OK, what you can call it as a decimal number. Now if I write X $ESI X dash D $ESI, then that address can be senior 0C. So you are getting next number. Is that fine? Okay, let us move further. Now you are getting next value. E6 become 8. 8 plus 8 16. EDI 330. Compare -1. No. Not add into sum. Increment ECX. ECX became 3. Jump. ESI. EAX. ECX. See the ECX and EX multiplication. It became 4 multiplied by 3. So 12. Add ESI, EAX. So 8 plus 12 would be 20. So you saw 20. You are fetching that value. So now next value is 440 from 20. NI. So it is 440 is with EDI. Check with -1. No. Move. Add into sum. Increment is 4. Jump. ESI again. EX 4. 4 4 16. ESI EX became 16. Add that 16 into 8. So 24. Correct. Take value at that address. EDI. You got 550. It is not -1. Continue. Add into EDI and sum together. So you got that sum. Increment ECX. ECX became 5. Jump to again LP. ESI array 8. EX 4. 4 multiplied by 5, 20. 28 should be there. Now if I try to print 28, it is -1. We can see here, correct? So now we are moving it to EDI. So EDI is -1. Now concentrate on these flags. Okay, you should see ZF there. Can you see ZF? Now see, like when we said Z, it never executed. Now it will go to that JZ. You can see this is JZ. This is print statement. Push, dword sum. Push MSG, call printf. Your printf got executed. Addition is 1650. Okay, so this is the code that we wrote. Now let us try to understand if I generate LST for it, how it will look like. Now concentrate here. This is we are moving to RM4. That's why this mod is coming into picture. We already saw in previous session. We are more interested into this kind of statement. Where we are seeing this dword of ESI. Dword of ESI. Instead, without adding this here, ESI here, ESI and EX together. Now what is the code here? We'll see what is the difference. Huh? So let me make the change. Sorry, Emacs. Instead of adding one more instruction here, like add, what I could have done here, I could have written here like this. Without writing this instruction. Without writing this instruction, I could have written that way too. Okay, but let us see like what is the change. See difference between both of them. Add ESI comma EX. So we are getting this 013, this one. Now we are adding this dword ESI EX. Now there are three things included. This is your opcode. This is mod RM byte. And this is scale index byte. And we will see how exactly it works. How exactly it works. Now, what if like instead of even why I'm doing this one, EX comma 4, ECX comma thing. So I could have written like this also. ECX multiplied by 4. Correct. So I am actually achieving this option array plus index multiplied by size. This is my array. So instead of ESI, I could have written here array. But then it will add something different. We will see both the statements. Let me write like this. Actually, both of them would be meaning the same thing. Same operation value would be given. Okay, by both of these. So let us see. But the code would be different. Code would be different. Let us see that code. See both of these codes. When your ESI got changed here, certainly you can see that instead of 8E, it is showing you 8D. And you are referring to array, which is a variable above. So if you see array, where is array? This is the address of array 000. That is the reason why this 000 is added here. So now we have to see, like, if at all, if something comes like this. So let me check this 3C now. What I'm taking? 3C. So what would be mod? In both the cases, I am getting 3C. In this case, I got 3D, but this was different and this is different. It was like memory register RM32, R32. In this case, R32, but again, there are computations happening. Correct. So I'm not really worrying about this part now. I'm really worrying about now what is this 3C. So because I want that kind of code. So let me go back and see my manual. Yeah. What were the numbers that we got? 3C. Let us check that in the manual. Where's 3C? 3C is here. You can see like 3C. What was the register? EDI. This is 3C and this is memory. It is referring to this part. Yesterday we saw about 042, even 052. Okay, so now we are getting this. But whenever we want to shift to something like this, so now how it would be? How it would be? Like it says +8. Let me work with this. Okay, so I assume like you might have understood how exactly this 3C came here in the code. When we saw this code, how exactly 3C came? Where's 3C? Yeah, here. This 3C was because you have EDI here. Now I'm not talking about this 8E and 8D. This is not part of my discussion right now. I'm neglecting that because it is part something else which I'm not referring right now. I'm only concentrating on 3C. So as there was EDI and some memory involved, because this definitely is an address, correct? Is this an address? Actually, yes, it is computing like this address of element, which I'm picking as a value by writing the word of that address. The word of that address. Okay, so I hope you understood now 3C part. Any question? Still, I haven't answered that 8E and 8D thing. Huh? It is not our role right now to find out answer for it. That would be starting very soon, probably tomorrow or maybe in next session. Not tomorrow, but like on Saturday or probably in next session, next week. But right now, we are more interested in this 3C kind of stuff. So if I replace the CDI by something else, you definitely would be seeing that it is some memory which you are referring to. And there are too many registers involved, not a single one. If it is an EAX only EDI, D word of EAX, then probably my answer could be different. My code generated could be different. In this case, if you see, you are getting 3D, EDI is used, and D word of sum. If I see 3D, where is 3D? See, it is written as displacement with EDI. We are using EDI there, na, directly. Yeah, D word of sum. So whenever you write it as a variable directly, without using any register apart from ESP, then it would be taking 3D if it is EDI there. And if it is EAX for it, then it will be showing me 0.5. If ECX, 0D. If EDX, 15. If EBX, 1D. If ESP, 2.5. If EBP, 2D. Or then ESI, 35 and then 3D. But whenever I'm entering into some other mode where I'm using a register and some computation inside in the bracket, the way that address was calculated like this. This was the address calculation mechanism which I followed. Okay, are you with me? Are you with me?
Yes, sir.
Chinmay?
Yes, sir.
Okay, I'm assuming you are understanding what exactly I'm trying to do. Nanesh? Okay, good. So I'm assuming yes, you are there, or you are having somebody who is typing for you. Correct? Adamchan. Yeah. So let us move on. So now I'm interested in something different. Okay, so let me first forward this code for you peoples to see exactly how assembly code could be written by you to take sum of array. Now same code we wrote, but there we haven't used this computation. We directly added 4 into that address. So this is same code but written in a different manner to achieve the same goal. So I like tomorrow you can enjoy this code, whatever the code that I transferred. Try to decode everything without writing without taking that LST. Try to decode it first on your own and see whether are you reaching to that particular point where your paperwork and what was shown there on the screen using that LST file is same. Try to verify it. So let me write another code now. Okay, so EX comma dword of PDX plus 4. Can you see code 42? What is the RM byte created? This 4, if you see this 4 you added is shown here 04. So if I take 10, then there should be 0A. So let me do that. Let me write 10. So this will be help like to for you, like whatever the last number is, it is for this. But you can see here it is showing you 42. Okay, let us go to 4. Let us try to decode 42. What was the code? I assume 42, na? Yeah, 42. Let us try to write 42 in binary. So 0, 1, 0, 0. Correct? 0, 0, 1, 0. Am I right? Is this 42?
Yes, sir.
Okay.
Yes, sir.
Now let us group it. So what is mod here? So you can see like which registers are there, which is 0, 0, 0. What is 0, 0, 0? EX is there. What is 0, 1, 0?
EDX.
Now you will see what are the instruction that I have used. EX is used at one place, CDX is used at one place. Now see this one. EX comma EDX plus 10. So EX was taken here. EDX number was taken here as the second part with mod to be 0, 1. It is because of this here. EAX plus displacement 8 bit value. 8-bit value, whenever you are taking 8-bit value, then you should see some value from here. So we got there 42, correct? 42, see here 42. 42 is EDX plus 8, square bracket EDX. You can see here, correct? And EX is taken as it is. So what happens? Let us see first what code gets generated. Suppose my register is EBX and here it is ESI. So my instruction is something like this. Move EDX, comma, dword of ESI plus 100. So let us write the code 0, 1. What is EDX? What is the number for EDX? 0, 1, 0, correct? What is the number for ESI?
1, 1, 0.
1, 1, 0, correct? Let us group them. Sorry. Now what is X number representation for this? 4 plus 1, this 5, correct? 4 plus 2, this is 6. So if you see EDX and ESI, see here ESI, this and EDX. Can you see 56 there? And I assume we got 56, but let us see whether are we going to get the same thing in the code. If I write same instruction, move ESI, comma, dword, sorry, what I wrote, EDX, comma, na? Yeah. Can you see 56? Now this 100 was translated to 64. So it is requiring still a byte. Correct? Can you see 56? This is 56. And this is what we got. So now whenever I do see pattern like this, see the pattern which is shown on the screen. This is the pattern that you want. If I see this kind of pattern and if this number is fitted into 8 bits, then I would be getting 0, 1 as mod. So let me increase that number. I'm taking same instructions. Now we are going beyond byte. Now this, I assume this will require some bytes, which are the number of bytes would be more than a byte. So now it doesn't have something called as 2 bytes, 3 bytes. No, it is directly 4 bytes. You can see here in the manual. See, either it is 8 or it is 32. Correct. Now let us try to conclude here. What would be the case? EDI is in bracket. EDI is in bracket. So you would be saying, sorry, what we use there? Yeah, EDX is in bracket. EDX here and EAX. So we should see something called 82 there for this first instruction. How about this EDX plus ESI? ESI is in bracket, ESI is in bracket, and we have registered as EDX. So EDX, this means third. So you should see 96. So we are more interested in what? 96 and 82. So let us see whether are we getting them here. We got 82 and 96. Can you see this? So whenever, now understand. So we will be finishing mod completely today. So whenever, if you have a register here included with a number added as plus, which can be fitted into a byte, single byte, then mod would be 0, 1. Now if I try to write this 82 and 96 है ना, दूसरा वाला क्या है? Yeah, 90 नहीं कितना है वो? Yeah, 96. So we'll try to write both the numbers. Now how will you write 82? 8 and then 2. Correct? Is it the way? I assume yes. 9 1 0 0 1 96 0 1 1 0. Is that fine? देखो 82 and 96 have I wrote correctly?
Yes, sir.
Now you group them. Now you see EAX, EDX, EDX, ESI. See the numbers. ESI is 110 here. It is 110. Correct? So we can see the same thing here that is occurring in front of you. So now what is the mod? Earlier our mod was 0 1 when it was a byte, but when suddenly the value was increased from a byte in terms of storage perspective, storage point of view, when it requires more than a byte, then ultimately your mod became 10. Your mod became 10. Now if I write there a variable here, if I write here A plus 10, A plus 100, A plus this, A plus this. Now see your codes. As it is with EAX, so where is A? A is not taken directly. This A was 0 0. That's why this got computed. We don't see anything here, but let us see with EDX. That became 1 5. Mod became 0 0. Because it is going somewhere here in a bracket perspective. Mod became 0 0. So what was the code? What was the value? 1 5. You see 1 5 here. Where is 1 5? E. Displacement wala. Right? With EDX. With EDX. With EX, we already saw that EX it is not taking anything. It is going to 0 0. When EX is and some address is used. It is showing because it is opcode mechanism is totally different and it is adding that in address of A this value. But then when I see this, what would be this? In both the cases, when it became 32-bit or 64-bit rather, sorry, yeah, 32-bit value means 4 bytes. It computed this A plus 1 2 3 4 5. This is the address which got generated because of this sum. And mod became 1 5. So it is not going, because if I write 1 5, ultimately mod would be 0 0. Mod rm byte is 1 5. So ultimately mod would be coming as 0 0, because if I have to map 1, if I have to see 1, it would be 0 0 0 1. So if I pick first two zeros, mod is already 0 0. Correct? Any question? You can ask if you have any. This was the earlier one. Yeah. Yes, somebody's. Yes, you can ask. Somebody unmuted. Yes. This mod is 1 1 for both these cases. For these two, mod would be 1 0, like 0 1. Sorry, I should have written there differently. Mod is 0 1, and for this mod is 1 0. On what parameters we are seeing this? You can check. If you try to write 8 6, it would be 1 9. Like 8 would be 1 0 0 0. 9 would be 1 0 0 1. So 1 0 would be common. That's why mod would be 1 0. In this case, if I write 4 0 1 0 0, 5 0 1 0 1. So 0 1 would be mod. That's why mod 0 1. Now in both the cases, like in this case, if at all mod comes into picture, because we took EX here, that's the reason from the instruction perspective. So what if I change the instructions? Fine. So I'm taking add. Let us see what happens. So see this 393, whatever was shown in bracket, same thing was shown in here. Now if you try to compare this 8639300, which was for ESI plus 1 2 3 4 5, same thing is here. With add. Now when variable is, then only that address was added there in 0. Same case what we saw here with move and add. Now if you compare this first add 420A, 420A, 5164, 5164, then 8639, 8639, and this whole thing 8639. This is first, second, third. So 86 would be your mod in this case. 9739, 9739. So we are saying that what is differentiating them now? The first part of code. In this case, ADB 03 and so on. But your mod RM byte remained same. Is that okay now? So I assume now you understood all 4 mods. Any question with them or about them? Yes, please. Yes, any question? So what is mod 00? Mostly it is register to register or register immediate, correct? Mod 00, no, I'm talking about mod 11. If it is register or register immediate. If you are including either of these registers into bracket, then mod 00 would be becoming. If you add something into that register, then 01 comes if it is 8-bit value. And if it is 32-bit value, then mod 10. Is that fine?
Yes, sir.
So now, see, we already saw how to find out opcode from the instruction set, how to form the mod. Now let us not much worry about opcode. What is the opcode? Now suppose if I only give you this parameter, this one, from any of the code, will you be able to generate that number from this whole set, starting from 000 to this FF? Can you write the code which will do this for you? Will you be able to write a code? What should it do? It should understand, it should read what is there added, because you saw in what cases what kind of mod is to be picked and how the mod RM to be picked. Though we haven't addressed all these combinations. So if you see, these are 8. These are 8. 8 multiplied by 8, 64 plus 64 plus 64 plus 64. So it is 64 by 4. These many entries. So if I give you any instruction, you should be able to generate mod for them. Now let me not talk about instruction. I'll only take the operands. So if somebody gives you a code with the operands only, the way that we wrote the code, you should be able to give me only mod. What would be mod? So think that would be your first assignment, or rather second assignment. Try to write the code. Okay, I hope you understood the problem. Deadline is Sunday evening. Sunday night probably. Okay, whoever is submitting before the time would be getting definitely credit towards it. Credit, I mean to say marks. Late submissions, copying would be directly given negatives. Negative, suppose if it is for 10, then if copied, then minus 10. If late, then minus 5 would be there. Like you would be getting marks out of 5 only. But I want you to write that code. What is to be done? What would be your input? Input would be only this. So you are not going to write this move. Your code will look like something like this. Your file will contain only this thing. You are going to read this, translate it into mod RM byte. So I want one of the number from this all 64 by 4 entries. Okay. Understood the assignment?
Sir,
Yeah. Okay. What will be input? So you are going to take instruction like this kind of operands. So I don't expect you write this. No, don't worry about this. I want this only EX, EDX, maybe D word. It could be variable or something else. But I like your instruction would be like this only. These 6 lines that I wrote here, including that mod. Let me do not consider that semicolon starting lines starting with semicolon. I want to talk about this one, this line, this line, this line, this line, this line. Similarly, if I give any kind of line like this, which are operands for instructions, but I don't know what the instruction is. I want you to generate this code the way that we generated here. ये 82, 56, ये जैसे 56 निकाला ना हमने, करेक्ट, we computed this 56, correct, even we decoded this 42. I want you to generate that 42, 56, like for example 56. Let me not worry about what is this instruction. For this thing, it should display 56. Is that fine? Is it clear now? Can you hear me?
Yes, sir. Yes.
Yes, sir.
Okay. So I assume now you understood the thing. So let me, okay, let me not save this.
Sir, we upload in Moodle, na?
Sorry. Yeah. I'll be adding I will be adding assignment there. Okay. I will add assignment there where you can submit this thing. So I have added both the codes for your reference. Okay. Try to complete it. So your deadline would be Sunday night, 11:59 PM. So my suggestion would be try to write that code on your own. Don't try to copy it. If you cannot do on yourself, take help, but don't copy the code. When I say take help, that doesn't mean that you take the code and you try to write it on the similar line. No, I have a plagiarism software which verifies that on Moodle. Okay, so I don't want you to get into that mode of getting anything copied, because probably very soon you would be in the department. Now, when you come in the department, you are going to show me every code, right? And I will be asking questions. So if I find something fishy, then you would be fired, kind of thing. Okay. See you then on Saturday. So we'll try to see like if I can start a bit early or maybe at 9:30, and if we can continue, we'll have a lecture from 9:30. So we'll continue till I get any call. So probably we'll take around 11 or 11:30. Okay, so we'll try to talk mainly about scale index byte, SIB. Fine. For